by different scientists. So let's discuss that. Charge to mass ratio of electron. What is charge to mass ratio? How it is identified and how it can be signified. Now let us see. In 1897, British physicist J.J. Thomson measured the ratio of electrical charge to the mass of electron, electrical charge to mass of electron, okay, by using cathode ray tube. We have already discussed cathode ray tube is a cylindrical glass tube. Both the side there are metallic plates which are acting as a anode and cathode, and when the high voltage is applied there, so what happens, the gas is filled inside with the vacuum, the gas particles gets charged, and the charged particles will start moving to the specific direction. If the charged particles, like discovery of electron, when we observed it, we have observed the charged particles were getting attracted towards positive plates. So that indicated the charge present on electrons was a negative charge. Now let us see the value of that charge also. So mass to charge ratio, when the cathode ray tube and mass of electric and magnetic field perpendicular to each other. Here electrical and magnetic field is applied which is perpendicular to each other. Thomson argued that amount of deviation of the particles from their path in presence of the electrical or magnetic field depends upon the specific factors. Now like this, the Thomson model is given. It is like a sphere and there are electrons present. We will discuss that in detail. So what are the points, how it effect depends on? First one is the magnetic of the negative charge of the particle, greater the magnitude on the charge of the particle, interaction with the electric and magnetic field, thus greater is the deflection. What we are observing here, first point is the negative charge of the particle, greater is the magnitude of the charge, deflection will be greater. Second, we are talking the mass of the particle, mass to charge ratio we are discussing here. So mass of the particle, lighter the particle, greater is the deflection. So what are the conditions? First is greater the negative charge, second is the lighter is the mass, lighter is the particle. Third point is when the strength of electric or magnetic field, the deflection of electrons from its original path increases with increase in voltage across the electrodes or strength of the magnetic field. How we are observing this? With the different kind of experiments we are observing, we are taking into account different experiments. We will discuss that. So what are the 3 points we have discussed? Just go to the previous slide now. What we are discussing here, amount of deviation the particles from their path in presence of electrical and magnetic field perpendicular to each other. So what are the conclusion after passing that? First one is more the negative charge, greater is the interaction between electric and magnetic field and greater is the deflection. Second is about mass, lighter is the particle, greater is the deflection. And the third conclusion is what is happening, the deflection from its original path increases with increase in voltage. So as the voltage is increased across the electrodes or the strength of the magnetic field is increased, we are getting the deflection, more the deflection. So in these 3 cases the deflection will be more. So let's discuss that. When the electric field is applied, the electrons deviate from their path in a cathode ray. Now you can see here cathode and anode, and the radiation is passing through it. You can see there are in a fluorescent plate, there are 3 points A, B and C. So you will observe it when the radiation falls on A, when it is on C and when it is on B. So when we are talking in the cathode ray, when there are only electric field is applied, so the point A, it will be, the rays will be attracting to the point A when the only electric field is applied. When only magnetic field is applied, then that time the rays will be attracted towards point C. When both the fields perpendicular are applied, electric and magnetic, then point B will be attacking. Okay, so let's see there. When the electric field is applied, electron deviates from their path and hit the cathode ray tube at point A. Okay, electrons are hitting to point A in presence of electric field. Remember it. Second is when only magnetic field is applied. When only magnetic field is applied, electron strikes the cathode tube with a point C. Okay, so when only electric field is applied, when only magnetic field is applied, that time electrons are getting heating to the point C. Okay, by carefully here point C we will underline, by carefully balancing electric and magnetic strength, it is possible to bring back the electron to the path followed, as in the absence of these fields, electric and magnetic field, they hit the screen to the point B. When both the fields are balanced, counteract, and the absence of electric field and magnetic field, they are hitting to the point B. Okay, so is it clear now what we have observed here? This particular experiment we are seeing in cathode ray tube only, the glass cylindrical tube. In that only, when only electric field is applied, electrons are getting attacked to the point A, only magnetic field, electrons are going towards point C. When both the fields are absent or counteract or counterbalance, that time point B will be taken into account, the attack of the site. Now let us see, by carrying the accurate measurements on the amount of deflection, what kind of, how much accurately deflection is taking place at A point, B point or C point, or different kind of experiment, set of experiments also. Okay, by the electrons on the electric field strength or the magnetic field strength. Thomson was able to determine the value of E by M. E is charge and M is mass. So charge by mass ratio is given by Thomson 1.758820 into 10 power 11 coulombs, okay, per kg. So this is the charge by mass ratio is given by Thomson. Now how it will be useful or how it will be applicable in future, let's see there. E by M ratio, which is given by Thomson, 1.758820 into 10 power 11 coulomb per kg, where M is the mass of the electron in kg and E is the magnitude of charge on the electron in coulombs. Okay, then since electrons are negatively charged, the charge on electron is always minus. Okay, so electrons are negatively charged particle, that we have already done with the help of cathode ray tube. Also there also we had observed, the when the high voltage electric field is applied, the particles are getting charged and that particles are getting attracted towards positive plate, which indicates opposite charges attract, so indicates the particles are negatively charged. So
it is a glass tube from which most of the air has been evacuated. When the two metal plates are connected to a high voltage source, the negatively charged plate, called the cathode, emits an invisible ray. The cathode ray is drawn to the positively charged plate, called the anode, where it passes through a hole and continues traveling to the other end of the tube. When the ray strikes this specially coated surface, the cathode ray produces a strong fluorescence or bright light. When an electric field is applied across the cathode ray tube, the cathode ray is attracted by the plate bearing positive charges. Therefore, a cathode ray must consist of negatively charged particles. We know these negatively charged particles as electrons. A moving charged body behaves like a tiny magnet, and it can interact with an external magnetic field. The electrons are deflected by the magnetic field. As expected, when the direction of the external magnetic field is reversed, the beam of electrons is deflected in the opposite direction. In 1897, J.J. Thomson, an English physicist, determined the charge-to-mass ratio of an electron. He adjusted the electric field so that the electrostatic deflection, theta E, was the same as the magnetic deflection, theta B, and was able to calculate the charge-to-mass ratio of an electron using the following equation, where E is the applied electric field, theta is the angle of deflection, B is the applied magnetic field, and L is the distance traveled by the cathode rays. Thomson determined the charge-to-mass ratio of an electron to be -1.76 times 10 to the 8th coulombs per gram.